I'm delighted to introduce Mark. He's the CEO, if I'm not mistaken, of Liquid Wire. And Liquid Wire have really an interesting technology because it is one of the most stretchable conductive ink technologies that you can come across. So, as usual, type in your questions in the chat on the right-hand side. We'll get all the questions answered. The stage is yours, Mark. 2 minutes before the end, I'll pop my head back in just to give you the heads up, and I will be asking you the questions at the end. So, over to
Great.
you.
All right. Well, thanks everyone for joining. Looking forward to talking about Liquid Wire and our technology set. So, like was mentioned, we have a fairly novel kind of quasi ink that we use to make interconnects. Now let's go ahead and kind of launch into our introduction. Um, so we've been around for about 5 years now in the field of flexible hybrid electronics, and we're fairly novel on the market in that we use a liquid metal conductor rather than a silver ink or other composite material. Um, and so we're mostly targeted towards wearables and on-body applications where you really need a lot of dynamic motion in an interconnect system. So just to kind of give you before I launch into exactly how we do everything and what the technology is, just to give kind of a quick visual of the types of things we work on is a lot of things like orthopedic monitoring and integration of microcontrollers and active electronics along with strain gauges into textiles. So this is a really full system design of flexible hybrid electronics. Although our main area of business is selling packaging technologies and then discrete components. So I'll get a little bit into this, what exactly we do as far as ink goes. And so what we have is a liquid metal, a printable liquid metal made out of gallium indium tin. And gallium indium tin is a well-studied alloy academically. It's a non-toxic, RoHS compliant alloy of, well, gallium indium and tin that melts at about 8 degrees centigrade and is very, very, very prone to supercooling. And it's been well studied in microfluidic systems for stretch electronics. Our main innovation at Liquid Wire has been to gellify it. So we do a cross-linked oxide structure inside the bulk of liquid metal, and it creates a very high viscosity paste that can then get patterned onto really almost any substrate because it's the mechanism of wetting it differs from a typical ink, and so it's really a mechanical placement. And the end results, once you print down this liquid metal, is a highly elongatable coupon, so interconnect. So here we have liquid metal patterned into a TPU elastomer undergoing, in this case, I believe is 100% strain excursion on this image. And it can just cycle to an unlimited degree because the paste remains fluid after printed. There's no cure stage. It's all room temperature processing except for the lamination steps, and a very wide operating temperature. And the actual conductor itself, because it is a liquid metal, it's functionally pre-molten, and it's very tolerant to high heat stages too if you want to do a solder attach step or something like that. So we'll further into it and just do a kind of an introduction to liquid metals in general. So gallium is a dominant metal in this alloy, and a lot of folks aren't that familiar with gallium. It's available on Amazon if you want to buy it as a curio. It's fairly well known as a novelty because it is a metal you can hold and melt in your hand, and it's non-toxic, unlike mercury. So it's fairly fun to play with, and it's been well studied because of its low melting point, high electrical conductivity, and then has a very low viscosity naturally, and it forms a spontaneous surface oxide. Our main trick is manipulating the surface oxide. And so these images are not from Liquid Wire. This is from academic work that has been done in the past, studying the oxide formation. And the oxide that forms on the surface of this liquid metal is a gallium oxide, and it's solid. So it's typically about 2 to 5 nanometers thick, and it's just enough to kind of hold a structure on droplets of this material. And so here you can see some academic work doing different patterning of liquid metals using microdroplet techniques. We go kind of one forward from that. I'll get to that in a second, but I want to cover a little